Indeterminate. We're going to talk about what does it mean. So anytime you have, make sure you can see, 0 over 0 or infinity over infinity, we call that indeterminate. And basically we have to take another step in finding the limit. All right. So there's three things you could do. You could do factor. You could, well, yeah, there's three things you could do. You could factor to continue. You could multiply by the conjugate, or what we call divide by the highest power of x in the denominator. So highest power of x in the num. All right, so there's three things you could do. So in this case, right off the bat, I see that I could factor because I can't just plug in 5 into this. We're going to have 0 over 0 because 5 squared is 25. 25 minus 25 is 0. And 5 minus 5 is 0. So I go another step. Keep my notation and say the limit as x approaches 5 is x minus 5. And this bottom is a difference of squares. So this is now x minus 5 times x plus 5. All right. Put a parentheses around here just to make it look nice. And we could immediately see that this removable hold is what is causing our function to be 0 over 0. So now the limit as x approaches 5 of 1 over x plus 5, all right, is just 1 over 10. All right, we just plug in 5, and this is no longer 0 over 0. Let's try another one. The limit as x approaches negative 5 of this function here. Well, immediately we can see that. Let's plug in negative 5. Well, negative 5 plus 5 is 0. Negative 5 squared is 10 plus 3 times negative 5, which is negative 15. All right. Minus 10. So plugging negative 5 here will also give us something that is 0 over 0. And you can just determine that immediately on a test, exam, etc. Right? So I'm going to keep my notation. I'm going to say the limit as x approaches negative 5. I'm going to factor this top right here. So this will factor into x plus 5, x minus 2 over x plus 5. All right? Because negative plus 5 times negative 2 is negative 10. All right? Adding plus 5 minus 2 will give us a positive 3. And we could immediately see that this is what's causing our function to be 0 over 0. So the limit as x approaches negative 5 of x minus 2 is negative 7. All right, negative 7 minus 2. Negative 5 minus 2 is negative 7. All right, so easy problems, polynomials, factoring, number one thing you want to do if your function is 0 over 0, if it's possible. Let's try another one. The limit as x approaches 1 of x to the 4th power minus 1 over x to the 3rd power minus 1. So plugging in 1 again, we get 0 over 0. So this is not an indeterminate. So what could we do? Well, I noticed that I could probably factor. And let's see. Right? So I'm going to factor the top. The limit as x approaches 1. I see that this is a difference of cubes, the squares, because I could factor this top as, well, x squared minus 1 and x squared plus 1. Yes, right? Multiplying these two will give me the same answer for this, right? And then I notice the bottom is actually, let's see, that's actually a difference of cubes. And so this is where you probably might want to have to know a little bit of formula, where it's applicable, right? So a difference of cubes says that, well, a cube minus b cubed, right? That is going to equal a minus b. Yes, it's going to equal a minus b multiplied by a squared, the opposite sign of the first term. So plus AB and always b squared. All right, so that's what the difference of cube formula says. So we're going to use this formula. Now the sum of cubes is going to be just opposite signs. So this will be a plus and this will be a minus. All right, so you got to remember that formula. So knowing that, I could say, okay, well, my x is going to be my a, and my -1 or 1 is going to be my b. So x minus 1 multiplied by, well, this is a squared, so I'm going to treat this as x squared because that's my a. I'm going to have a plus sign because that's what my formula tells me. All right, ab. So well, x times 1, this is a, this is b. X times 1 is just x, right? Plus b squared, which is just 1. So 1 squared is 1, and that's going to be my formula. Looking at this, we still have 0 over 0. So I'm going to say, okay, well, the limit as x approaches 1. I can factor this. This is a difference of squares, you see? So I could say, well, x plus 1, x minus 1, multiplied by x squared plus 1, divided by x minus 1, times x squared plus x plus 1. All right? These could cancel. And now we can just see that our limit as x approaches 1 is going to be x plus 1, x squared plus 1, over x squared plus x plus 1. Right? And now we don't have a problem, right? Because now we don't have 0 over 0, so we can just plug in 1. So plugging in 1 will give you 1 plus 1, which is 2. This is also 1 plus 1. So 2 times 2 is 4 on the top, right? And so 1 plus 1 plus 1 is 3, right? Because 1 squared is just 1. And so the limit is actually 4/3. So a lot of arithmetic, a lot of problem here, but it's what this is what we have to do to tackle some of these indeterminate problems.